And then, okay, so I just, yeah, I ferociously had, I realized I'm so absent-minded. I created all these files. I wrote all, kind of revised these files yesterday, and then I, realized right before the lecture I never uploaded them to to Canvas. And so that's what I was doing at the last minute. Um, but are there any questions on while loops or any, and students, just remember, at any point you have a question, I mean, either here or between, because the next time we're not going to see each other again until Monday. So if you do have any questions, just email me. And the best thing to do is just email me like your code, either attach a file or actually copy the text of your code into an email, because that allows me to run it, and then I can see where maybe any possible errors are. And then we can always talk on Zoom, and then you can share your screen with me if you think that would help. So any questions right now on while loops? So because otherwise we're going to continue today with more loops. We love loops, and so students, if you like computer science, I'll exchange. I was going to say, if you like computer science, you like loops. No, if you like loops, you're really going to like computer science. Okay, so loops are, if you think you're going to be a computer science major, yeah, loops are in your future, and they're really important. It just allows us to do the same thing over and over and over. Yeah, I'm looking at this insect that's on my desk. Luckily I'm not scared of insects. I mean, I guess if it was like huge, yes, I would be. If it was like a tarantula or something, then yeah, then that would be normal. But no, it's just a little tiny insect. Um, though I do know people who are very scared of insects. Okay, but anyway, that's really not relevant. Um, so we're going to talk about for loops, which in this course is probably going to be more, we're going to use a lot more than while loops. And the one thing I noticed in Math 140 is how students have a harder time with while loops. And I think it's just lack of experience. So I'm going to hopefully throughout the course just kind of remind us how to write a while loop. And because I noticed that like in 140, students will kind of try to make their for loops be like, they'll use a for loop when they really should use a while loop. And so a while loop is really good when we don't know the exact number of iterations. Remember, an iteration is every time we cycle through every time we execute a block of code in the while loop, that's an iteration. So like in that example we did last time in the PowerPoint slides, and the one that I encourage you to read for the assignment is like adding up all the numbers we enter like an integer like 421 or whatever, but and then you're asked to add up all the individual digits, 4 plus 2 plus 1. Well, we don't know the number of individual digits in that number, so a while loop is great for that, because in this case it's 3, but a user can enter an integer of length 4, like a 1008. And then we'd add 1 plus 0 plus 0 plus 8. So a while loop is really good when we don't know the exact number of iterations for a loop. And where a for loop, which is what we're about to learn, is really perfect when we do know the exact number of iterations. And we won't really make good use of for loops until we talk about this topic, which is going to be a very important topic after the quiz, after the exam, and that's arrays. We're going to talk about arrays. Really very, which is like a list. So a list of fixed length. So for loops and arrays really go good together. I do have one example with strings, I think, in this in here that's useful. So the PowerPoint slides are online. I'm going to share the PDF file of the PowerPoint slides are online, and I'm going to just share the screen now. And we're going to learn this totally new topic. So for loops are a little more complicated. And I'm also going to point out some kind of, we'll get to it. Okay, but let me share the screen. Let me see the PowerPoint slide instead of just, okay, I think this is it right here. And sharing, share. Okay. So, okay, for loops. Okay, so, and then, okay, so hopefully we'll learn the syntax of a for loop, and when we, and I basically already said, when should we use a for loop instead of a while loop? When you know the exact number of iterations, some common syntax errors. Okay, so that last thing, now that I look at that last bullet item, it might look kind of strange. So remember, a string So it's an algorithm for counting the number of digits in a string. Well, we can actually have digits in a string, right? A string is just a sequence of characters surrounded by double quotes. So, you know, like if I surround, let's say 123 by double quotes, it's not an integer, it's a string. Okay, well, we'll get to that. It's kind of a fun example. Okay, so again, so loop is, we learned about loops last time. It's just a mechanism for executing one or more statements over and over again until some Boolean expression. Well, it'll stop when the Boolean expression is true, and I mean, it stops when the Boolean expression is false, and it executes another iteration when the Boolean expression is true. So hopefully I kind of did this right last night. Okay, so I was kind of looking at this. Okay, so here is the basic format for a for loop. And you can see right now it's a little more complicated than a while loop. In a while loop, we would just say while, and inside the parentheses, it would just say Boolean expression. Now, you see there we have three items in there. We have the initial condition, and then in the middle we have the Boolean expression, and then the last thing, I'm calling it the incrementer, but it could also be I'm just going to call it increment. Let's see, it doesn't actually, we don't actually have to increase, we could decrease the value of a variable or increase, but I'm calling it the incrementer for right now. And then inside the curly braces, those are we have Java statements that execute if the Boolean expression is true. So let's just take a look at this. So the initial condition executes just one time. So we get to the for loop, and so this part right here, that I'm going to highlight, I always seem to highlight in red. Okay, so that part executes one time. So we just initialize some variable. And then the next thing we do is we evaluate that Boolean expression. And if the Boolean expression is true, we go to step 3, which is execute the Java statements. And then we execute the incrementer. Okay, and then we go back to step 2. So it's Boolean expression, Java statements, incrementer. And as long as that Boolean expression is true, then so if the Boolean expression is true, we start another round of the iteration. So Boolean expression, Java statements, incrementer. And then eventually that Boolean expression has to better be false, otherwise this loop never ends. So let's just see our very first example of a while loop. Okay, so I want to add up the first 4 numbers, 1 plus 2 plus 3 plus 4. Okay, which is not really, it's not a useful, it's a simple example, but it's not like, I mean, we could do that in our heads. Okay, so we don't need the computer to do this for us, but it's a good example. And the one thing I like about it is, okay, so a lot of times in loops, we do add up a sequence of numbers. Like let's say I want to know, let's say I want to know to compute the grade, let's say I have a school, like a big school like Southwestern College, and I want to compute like the average grade point average for every student in the school. Well, there's thousands of students. We're certainly not going to do that by hand. We'd make a mistake. So this would be a great thing for a for loop. You know, you add up all the grade point averages divided by the number of students, and then you get I guess the average. You get the average of the grade point averages. Okay, so okay, but the one thing, so adding up a sequence of numbers is a really common operation in not just Java, in this computer programming. And so if you're going to add up a bunch of numbers, you have to store it in something. So this, I probably should have highlighted this more. So you need to, so this is a variable to hold the sum. So okay, so if you're going to add up a bunch of numbers, you have to have a variable to hold the sum. So this is really common that before the loop, I say int sum is assigned 0. Because we're adding up a bunch of integers, I declare it as int. If we were adding up a bunch of double values, then it would be declared as double. And there's nothing special about that term sum, like SUM. That, you know, it has meaning. So we want to use meaningful variable names. So it's meaning to us. But the computer doesn't care. You could call it, you know, XYZ, and the computer doesn't care. But yeah, we want to have meaningful variable names. So when I see the word sum, that means I'm probably storing the sum of something. And then see every iteration, we're adding on the latest value of I. So we initialize this. So notice that what I'm doing here, this is also different, is right here. Let's just look right here because Okay, so I'm actually declaring the variable I right inside the loop. And I'm initializing it to 1. This is something that if you've never seen this would be, if you haven't seen a for loop before, this is totally new. So right inside the parentheses, we're declaring the variable. And I think I even say that in my comment. So this, yeah, okay. You declare variable in the loop, and that happens 1 time. So we initialize I to 1. And then remember the order, it's Boolean expression, Java statements, incrementer. Okay, and then I++ means increment I think I say in the next page, I++ means increment I by 1. And so here, that language C++, it's kind of, it comes from that plus operator. So plus just means increment the variable by 1. And okay, so initialize I to 1, because initially I is 1, 1 less than 5 is true. So the first time, what are we going to do? So the very first time, it's going to be, so the very first iteration it's going to be sum is assigned sum plus 1, right? Okay, and so and so the value of sum is initially 0, so we would just change sum from 0 to 1. And the next time we would add on 2. So we get all these so we're building up these partial sums until eventually it's 1 plus 2 plus 3 plus 4. And then in the next slide, I think see, the code example 1 is equivalent to this right here. Okay, so right, we initialize. So if you look here, yeah, we declare sum, right? And then we declare a variable I, initialize it to 1, and then we have a bunch of statements, right? Sum is assigned sum plus I. Remember, that looks like a bad. So if this is calculus, you get an F, right? So you have the sum. You subtract sum from both sides, and you have 0 equals I. Okay, so remember, that's not an equation. This is an assignment statement. You always start on the right side of that thing that looks like an equals. So in Java, in computer science, that a single equal is an assignment statement. And so you start on the right side. And so 0, they take the latest value, 0 plus 1 is sum. So now, in this case, sum is 1, right, after that. And then we increase I by 1. So I goes from 1 to 2, and then we execute the same. We execute sum equals. Sum is assigned sum plus I 4 times. So now what is it? We're adding on 2 to sum. So sum is assigned 1 plus 2, which is 3. So now sum is 3. You increment I by 1 more time. I is 3. So now what are we adding? We're adding 3 plus 3. You get 6. And then you increase I by 1 more time. You get 4. And so now I is assigned 6 plus 4, and you get a 10. And then when I becomes 5, we would stop. So let me just go back. Any question? I'm just going to go back to the previous slide. Okay, so this should be up in the modules, by the way. Okay, so that's what that loop did. So the one thing about a for loop is it stops when that Boolean expression is false. So eventually I does get the value 5. And you check 5 less than 5 is false, because 5 less than 5 is false. And then you would actually jump. So when I is 5, you actually jump to the first statement after the for loop. So you keep it. So again, we start sum out at 0. We have our for loop. We're declaring the variable I inside the for loop. Can we do that 1 time? You check the value of the Boolean expression I less than 5. 1 less than 5 is true. So you increase the value of sum by 1. And then you go up to the incrementer. I++ means increase I by 1, so I is now 2. 2 less than 5 is true. So now you increase the value of sum by 2, and so forth. And then you increase the value of I by 1, you get 3. 3 less than 5 is true. Increase the value of sum by 3. Increase I by 1, now you get 4. 4 less than 5 is true. Now increase the value of sum by 4. And now increase the value by 1, you get 5. 5 less than 5 is false. So then you print out sum equals. And in this case, it would print out sum equals 10 for this particular example. It's a good thing, yeah, good thing I didn't make the let's sum up the first 100. Yeah, we'd be here a long time if I was going to do it one by one. Okay, so this is a really basic, this is a really good example to know about for loops. And this is what you see in a lot of books, you know, this kind of declaring the variable inside the loop. And that I++ is really common, where we increment the value of what I call the counter variable, that's my term, I guess, the counter variable by 1. And I will tell you, the Zybook does it, is a little non-standard in this, and I'm going to talk about it. Hopefully I'm going to talk, I'm pretty sure I typed this up last time. I'm going to talk about it in the notes. But any questions so far before we go to the next slide? I think is page 7 here. Will it be slide 7? Okay. Okay, so the previous example declares I inside the for loop. So this is standard. Most books follow this approach. So if you happen to have maybe you have a Java textbook or just a Java, you know, how to program Java in 21 days book, or that is what you're going to see. Or if maybe you go on YouTube and you look at some videos, and that I++ means increase I by 1. And most books will also put the plus on the right of the I. Okay, so now we're going to look at a new example here, and we're going to declare outside the loop, and we're going to put the plus on the left. And why I'm doing this, because this is what they do in the Zybook. And so it actually is non-standard, and I'm not sure I'm not sure I agree with them it's the one thing that maybe I don't want to undermine the book. I think it's actually I think it's great the way all this. You get this instant feedback, and they're really picky about your output. To be honest, I've written some of these programs, and I go, oh my God, I'm not getting the right output. And it's because of my end-of-line characters. They're very picky, which I think is great. This is the one thing I might change about is what they're doing right here with the for loops. So let's take a look at this. Okay, so this is the Zybook version of example 1. Or they don't actually have this example, but this is how they would write it. Okay, so again, we're going to add up the first 4 integers, 1 + 2 + 3 + 4, and we're going to use a for loop to do it. I don't need a for loop to do it, but it's just because it's so simple, but you know, we have to start somewhere. It's just a very simple example. Okay, see how they declared what I call the counter variable outside the loop, where if you go back, I'll just go back really quickly to slide 5. See how I do it inside the loop, and that's what you actually see in almost every book. The Zybook does it this way. I think they think that for new students, this cuts down on errors. You know, they probably have done some research and maybe they found that, but I will tell you that it's not standard. That's all I'll say, and I'll just leave it at that. Okay, so in all their examples, I think they declared the counter variable outside the loop. And so notice here, inside, see how that for loop, we don't say int in front of the I. See here, I declared the variable inside the loop. So this is the first time we see I, that variable I. So we have to say what kind of variable it is, and we declare, you know, we have the variable type to the left. Okay, so here they're declaring variable I outside the loop. So now when they initialize I to 1, you're not seeing int in the for loop. The other thing that's non-standard is, see how the plus is to the left? That also means increase I by 1. And there actually is a difference, and maybe, I'll show you an example next time, which is, I'm not sure they actually have this, and I have to look to see if there's actually a section on this in the Zybook. There can be a difference between ++I and I++. In this case, there's no difference. In both cases, it just increases I by 1. And maybe at the end of the lecture, I'll show you. It's really not that hard. I'll show you at the end of the lecture. Okay, but for our purposes, they do the same thing. I'm just saying in most books, the plus will be on the right. And in most books, the variable I would be declared inside the loop. But it's the exact same calculation. Okay, so any questions on that? So I just have, okay, so the rest of the slides are just more examples and also just places where that can kind of ruin your life. That's the thing about the for loop versus the while loop. There's all these little gotchas that kind of can make your life very unhappy. Like it's like 1 in the morning, you're trying to write this computer program. Why isn't this working? Okay. So once again, the difference between example 3 and that first example, I put a print line statement inside the loop. So you would actually see this execute every time. And so, and I'm going to show you, we're going to do some coding. I have one file that's up there, but so in this case, you would actually see, unlike the previous loop example, you'd see intermediate sums. So this is good for debugging. You're writing some code and you're writing this for loop and things aren't going well. You can just put a print line inside the loop and that helps. And then, so let's go, okay. So, and so here's just, remember what I said that this term here, remember I go initializer, Boolean expression, incrementer. The incrementer can actually be decrement. I mean, you can actually increase I or decrease I. And see how that I minus, that means decrease I by 1. Oh, looks like. So I start I out at 4. 4 greater than 0 is true. Increase sum by 4, and then decrease I. Okay, so when I is 0, we stop. Okay, so here's the equivalent while loop. Okay, so here, yeah, you have to, the counter variable is declared outside the loop. Yeah, once again, here we just, again, and every time, you know, you'd be adding up 1 plus 2 plus 3 plus 4. Let's maybe get to a more interesting example here. Okay, so here, why don't we, here we can, whoops. Why don't we, where was I? Well, yeah, I should have, I do have one Java file up there. Let's just create a couple more. These are a little more interesting here. So here, I'm just gonna copy this and let's see here. So we're gonna add up the first, all the even numbers from 2 to 100. So 2 plus 4, and then there's a formula for this. So we'll see if we get the right answer. So I'm just gonna copy this. And I'm gonna go into Eclipse, and so I'm gonna stop sharing right now and share Eclipse. But just remember to stop me if there's any questions and anything. And then so let's share Eclipse. And I'm going to create a new file. So here's I call it for loop example. So I'm gonna let's just create another file right here. So how about another I'll rename these, but how about a summing? Sum with loop, sum with loop. I don't know. Okay, and then, oh, but no, wrong place. There we go. Okay, so we create things. So our file name is going to be called sum with loop. Oh, yeah, I'm going to be smart. I always forget to do this. You just put that check mark there and it puts in the main method for you or for us. Yeah, so, and then I don't really like this comment. See this like to do, it's generated by Eclipse. Well, we don't want to give this to anybody we actually know. So that's, oh shoot, now I'm gonna go back to you can't see what I'm doing right now. So I'm gonna go back and copy everything that from that PowerPoint slide. Okay, so okay, so then why doesn't it like me here? Okay, declare, what does this say? Why it doesn't like one of my, yeah, since I'm copying and pasting, it doesn't like, it doesn't like something I copied from. Oh, it didn't, I guess I didn't like that blank line. Okay. That I copied from. That's the one thing about copying and pasting from Word or from PowerPoint slides into Eclipse. Sometimes you get these characters that Eclipse can't recognize. And sometimes they're invisible characters. You can't really see them, and it's very frustrating. Okay, so if you look at this, okay, so we're going to add up. So what does this do? So we're finding the sum of. So what does this program do? It's computing 2 plus 4 plus 8 all the way up to it. we're adding up the first, yeah, we're adding up all the even integers from 2 to 100. And so in this case, we start our counter variable I'm calling k. Oh, so once again, students, remember, when we're computing a sum, before we start the loop, we have to have a variable that stores the sum. And the terms, and I think the variable named sum is a really good idea. So again, nothing special. The computer doesn't know what sum means, but we do. Okay, so we initialize the sum to 0. And each time we add on k to the sum, okay, so first we initialize k to 2. We do that exactly one time. And then we check, is 2 less or equal to 100? Well, the answer is true. So we increase the value of sum by 2. And then we come back, and then we go up to what we call this incrementer right here. K is assigned k plus 2. We increase the value of k by 2. So now k is 4. And you check, well, is 4 less or equal to 100? It is. So now increase sum by 4. And we're not going to do all of them up to 100. Eventually, yeah, so eventually k is going to get the value of 102. Right, so eventually you get here, eventually k will be 102, and you check, is 102 less than or equal to 100? And the answer is false. And that's when you go to the print line. Okay, so let's just run this. It'll hopefully go really very fast. And yeah, we get the sum as 2,550. So let's see, which one was, okay, so let's, 2,550. Okay, so there's actually is a formula. So what we're adding up, we're going, so isn't this equal to, let's see, 2 times 1 plus 2 plus 3, all the way up to, I'll take a short here and just go plus 50. If we distribute the 2, you get all these numbers here. So we're adding up the, so we're taking the sum of the first 50 positive integers and multiplying by 2. And this is actually, students, if there's a formula for this, and then this, it should be 50 times 51. Oh yeah, and I think that's, we got the correct answer, isn't that right? So 2,500, yes, yeah, so we got the right answer. This is equal to. So, and if you're not familiar with this formula, when you take, if you have calculus, right? If you've had calculus, you've learned that 1 plus all the way up to n, and maybe you learned in some of your other classes. Maybe you might have even learned this in your algebra class. So I'm just using that formula, and if you multiply it by 2, that's what I'm saying is the sum of the first n integers is n times n plus 1 over 2. You multiply that by 2. And so then it's just, so the formula for our sum is just n times n plus 1. Yes, we actually got the right answer. But the important thing is not so much this algebraic formula. The important thing is understanding this loop. So in this case, it's a little more advanced than what we did before. Instead of starting the k at 1, we started at 2. And we also are, instead of incrementing k by 1, we're incrementing k by 2. So in this incrementer, we can do anything we want. We can add or subtract. We can divide and multiply if we want. So any arithmetic operation is what I call the incrementer. Is really, it's just like it's a crazy world out there. I mean, it does. So this is I say, just go wild when you do this, or actually do it, or do what the problem calls for you to do. Okay, so students, we're going to maybe go back and forth between Eclipse and the PowerPoint slides to do some of these examples here. But are there any questions right now before I go back? Let's maybe go to the next example in the for loops. So let's go back here. Oh, whoops. Forgot to share this. Okay, so we just did that example. And then what's our next? Okay, so this is, what's the next one? Oh, this is the fun example that I was talking about. So I'm gonna, we can try this one if we want in the PowerPoint. Why don't we try this one also in Eclipse? And I'm gonna have to fix, yeah, my single quotes will not work right. So I'm gonna have to, so when we get to Eclipse, we'll have to change the single. I'm sure those Eclipse won't recognize those single quotes. But why don't we just take a look at this and then we're gonna try this. So remember what I said before, it looks kind of funny. string can have digits. So I'll just type this right here. So there's a comment here. Is that, so like 1, 2, 3 is a string. It's surrounded by double quotes, and 1, 2, 3 without the double quotes is an int, and they're not equal to each other, right? So you take those characters, you take that sequence of characters 1, 2, 3 surrounded by double quotes. Now you have a string. So and I don't have to have, and I can mix digits and anything on the keyboard. I can type inside the double quotes. And so what I am saying is let's enter a string. We can ask the user to enter a string, but maybe we'll just hard code it for right now to make it simple. I'll post a version where the user is adding reading in the string, and we're going to count the number of digits entered by the user. This is actually useful for error checking. So like on websites, don't you have to have like they're asking you to enter your address or like an area code or a zip code. And a zip code is five digits, right? And so the web developer has to make sure that the user has entered, hasn't put, like, maybe accidentally made a mistake. Instead of maybe they entered they entered a letter, an alphabetic character instead of a number. So they do these on web, it's behind the scenes, it's on the web server, where they're where they're parsing the individual character. So one thing I'll say is, when you enter like data, like into a text box on a website, it gets read in as a string. Okay, so then on the website, so you type in your zip code, you press the submit button. So then there's a computer program running on the web server, which is often written in JavaScript, which is kind of like Java. The syntax is really very similar. And so it's taking that zip code and it's doing some error checking. First, it's checking to see, oh, is the length 5? And then it's checking to see, are the individual characters all digits? And so then it has to parse that string one by one and check that each individual character is a digit. So, looking at the individual characters of a string and, seeing if it's a digit is a really very common operation for a website. And I mean, so what I just said is so common that it's pre-programmed, right? So, like 20 years ago, every web developer in the world was doing exactly what I just said, writing code that checks to see if the user is entering a valid area code or zip code. Now there's like these there are packages that people buy because it's so common, just to make the web development go faster. So, okay, so what was I know this isn't a web. I misspoke when I said that when you press the submit, it doesn't actually go to the web server. The JavaScript runs on your computer, so the browser is actually checking it before it sends it to the web server. Sorry, just a right. So the JavaScript is actually running on your computer, checks to make sure that you've entered a valid zip code, and if the zip code is valid, then it sends it to the web server. Okay, sorry about that. Okay, but checking a string to make sure there's parsing the characters of a string one by one is a very common operation. Okay, so let's get on with this example. Okay, now I distracted us with that. Okay, so we're going to count the number of digits in a string. So in this case, it would be 3 because there's 3 characters. So let's say, once again, 1, 2, 3, AA. So our loop would return 3 because there's 3 digits. So I am going to, let's just copy this and I'll get rid of that comment when we get to the, when we get to Eclipse. So I'm copying this and I'm going to stop sharing. So let's go back to Eclipse. I better share Eclipse. So let's just create a new file. And I'll just call it, I don't know, digits, I don't know. No, I keep it in the wrong place. Once again, I remember to put that main method in, so I'll just wipe out this comment. And I don't need this comment. And so it doesn't like, it doesn't, definitely does not like. And we have to declare a string. Okay, so I haven't. So we would just read this in, but just for brevity's sake. So let's put in, how about like 1 and how about 3, and we got a bunch of others. So we can even put comma, semicolon. Let's close off the string. So how many individuals? So we see there's 1, and then there's 2, 9, 0. 0 looks like, oh, let's get rid of that. How about 6? Okay. Okay, so 1, 2, and then 9, 6, 3. So there's 5 individual digits in there. And so we're going to write this program. And so now we're actually, I think there's a section in this in the Xi book, strings and loops. So here's just the first example of that. And so this is a very nice example of when we'd use a for loop. We know the exact number of characters in a string. We learned this like a week ago. The number of characters in a string is given by that length property. Okay, so length tells you the number of characters in any string, and you have to follow the length by parentheses in a string. So we know the exact, so if we're going to look at that, if we're going to look at all those characters one by one, we need to know how many that we're going to look at. Okay, so this is a perfect example of when we'd use a for loop instead of a while loop. We know the exact number of iterations. And I don't have to know the number of characters in that string ahead of time. I mean, I could actually add more characters to this. How about, like a T and an R or whatever. And it's still okay because length will always give us the right number. Okay, so so now we're going to count the number of digits we see in this string, or they're contained in that string. And so we have to declare a variable to hold the count. So I think count is a pretty good variable name. I think sum would be a bad variable name because we're not computing a sum. We're counting now. So let's just let's have meaningful variable names. So when I see the word count, I think, oh, okay, it's storing a count. Okay, so now we're going to look at the individual characters. There's other ways we could do this where we don't have to declare this car variable, but that's what I'm going to do. I think this makes it a little bit simpler. Okay, so we're going to declare a car variable and I call it ch. Okay, so now we're going to look at every individual character in this string. Since I am so much in the habit of declaring my counter variables inside the loop, but if you don't do it because that's in the Xi book, that's fine. Okay, so you declare the variable inside the loop. I call it kk. Nothing special about kk. It's a legitimate variable name, and we initialize it to 0 because remember in a string, the leftmost character is at position 0. So remember, every individual character in a string has a position number. And in Java, computer scientists like to start counting from 0, so that 1 is at index 0, and that first H is at position 1, and the second H is at position 2. So computer scientists like counting from 0, and so we initialize kk is going to be the index. We initialize it to 0, so we do that one time. Then we check to see, is this Boolean expression true? Well, I don't know how many characters are in that string, but I know it's more than 0. Okay, all it has to do is length 1. So 0 less than some positive integer is true. And now what we do, here's the interesting part, students. We go inside the loop. And the first thing we do is, remember the first time, so in the first iteration, what do we have here? We have ch is assigned string, it's str dot car at 0. So in this case, ch is this individual character 1. So the first time ch is 1, and then the next iteration will be h, and then h again, and then f, and then t, and then e, and then it'll look at every single character one by one. And then we check. Here's our if statement. And luckily we can check to see if a character variable is a digit with this Boolean expression right here. Is ch, we can compare character values with greater than or equal to. So is ch greater than or equal to 0? But the 0 now is in single quotes. It's not the number 0, it's 0 inside single quotes. The character 0, and is it also less than or equal to the character 9? See, they're both in single quotes. And if that's true, we increase the value of, this means increase count by 1. Okay, so increase count by 1. Okay, so, and we could go count as a sign count plus 1. Okay, so so every time we get to a character that's between 0 and 9, we increase the count by 1. And then at the end, we can print out the number of, okay, so when kk is actually equal to the length, eventually we increase, so can we go through this first iteration? We check to see is 1 between 0 and 9, it is. We increase the count by 1, and then k will become 1. Then we increase the value of kk by 1, and then the next time we're taking car at 1, and then ch will be h. But eventually kk will be equal to string.length, and we stop. So we'll print out system.out. I'll make this shorthand. Not a very nice message, but not very user-friendly. Why doesn't it like me? So because I'm using I didn't use the variable name I said I was going to use, count. Okay. So why don't we just run this and see what happens? Yeah, num digits is 5. And so now we can actually read in the user could actually enter a string from the keyboard. And then we can actually, so basically we can actually parse any string we want. So this is actually, these lines right here, like 8 through 10, that's how we parse the individual characters of a string. And then after that, what we do with the individual character, might be different depending on the problem. But those lines 8 through 10, that's really a classic way of parsing the individual characters of a string. So this kk is less than the length of the string, and then we get the individual characters one by one, right? Kk is 1. So second iteration, I'll just do one more. ch is, what is it? In this case, it's h. Yeah, so one by one, you'll get all the characters. And so students, there's other ways of writing this problem where maybe fewer lines of code, but maybe the lines are longer. And just one last thing about, not that this is something you actually need on a test or anything, but what's actually going on here is that every individual character on your keyboard is actually associated with an integer that's called the ASCII value. So what we're really doing is we're comparing the ASCII values we're comparing the ASCII value of whatever ch is storing with the ASCII value of 0 and the ASCII value of 9, which I don't know what they are. You can look up these ASCII values, but we're actually doing an integer comparison there. Okay, so but luckily the ASCII values of the characters 0 through 9 are all grouped together. So this tells you, so if true, okay. So you just go through this loop, get the character, check to see if between 0 and 9, if it is, increase count by 1. Okay, so students, any questions on that example? And I think this is a really good example. This is kind of, I'd say, an intermediate example. Maybe, and again, so students, gradually the examples are getting harder and harder. But this is, I don't know, this might be one of the harder things we've done in this class so far. There's a lot of things going on in here. First of all, you have to remember some of the stuff we've done from, the previous lessons. Like, that length, to get the length of a string, we have to use the dot length. To get the individual character of a string, we have to use charact. We've got this if statement going on. We have to remember that we can compare characters with the greater than or equal to. Now I've introduced some new things. I think that might be the first time we've done the plus plus, and definitely the first time with the for loop. So there's a lot going on here. If you're new, there's definitely, this is a good example because it kind of, it requires us to know everything that went on, in the last couple of weeks. So.
I'm curious about this. We're counting the number of digits.
Right.
How different will it look if we count the letters?
Okay, so the thing with letters is, remember, a letter can be, there's actually a function, the book uses this built-in function. There's actually I don't know I have to look it up in the Xi book. There's actually a built-in function that tells us an individual character is a letter. I think there's a built-in function called character.isLetter. We can try that. If I was going to write an if statement like this with 12, if I was going to do it manually instead of using some built-in function that's built into Java, the thing about letters is that you got the lowercase and you got the uppercase. So if you wanted to know if it was either lowercase or uppercase, you'd have to, there'd be it's two different cases. First, you'd have to check, is the character lowercase? And if it's not, then you'd go, is the character uppercase? But here, let me just type it as a comment down here, or just, so like, if you want to know if it was a lowercase character, if I wanted to do this if I wanted to do it manually and I'd use some built-in method, so this is, is lower, is car lowercase. My screen's so dirty, I can't read what I'm typing. Is car ch. That's how you check if it's a lowercase. But you have to check lowercase and uppercase separately. Because remember what I'm saying, what's going on behind the scenes is you're comparing ASCII values. So, and I happen to know the ASCII value for lowercase a is 97. That one I know. And the ASCII value for Z is 122. I just added 20. I added 97 and 25. They're all in consecutive order. So basically you're saying, is the ASCII value for CH between 97 and 122? And if it is, you've got a lowercase character. And then you have to do the same thing for uppercase. It's uppercase A, it's 65. Okay, but there's actually another way of doing this. I think this is there's actually a built-in function in Java, and I think I'll double check this. You would say is character, I think you actually type the word character with uppercase C, and I think it's is letter, CH. And that's a built-in method in Java that will tell you if your individual character is an upper or lowercase letter. I think that works. I think they have an example like that in the Xi book. I think it's in section. They have a section in chapter 4. There's a section I think with loops and strings, and I think they have an example like that. So I kind of like this, what I'm doing there on line 22. It takes us a little more skill. Of course, you have to memorize this too, so that, a certain amount of, because this is actually probably common to use what I see there on line 24. But to answer your question, Richard?
Yeah, thank you.
So, okay, anybody else? And then I know it's getting kind of long, so I have a few more. See, if I was teaching this in the classroom, it'd be a combination of my lecturing and then I'd be going back and forth. But now it's mostly because we're not in the classroom where there's kind of like I can't walk around the classroom and see what and helping you. So, so I'm going to stop sharing this. Let's see if we can finish this lecture because I know it's kind of long. And then, so let's go back to the slides, and I'll just talk a little bit longer here. So I'm going to. Remember, students, if you want to. I encourage you to stay, but I'm not kicking anybody out. But at any time you feel like this isn't serving your purpose anymore and you want to leave, you're not hurting my feelings. Okay, and I'm not actually noticing. I mean, I am noticing, but I'm not like writing it down. A so-and-so left. I have like a diary of everyone who's, I don't really. No, okay, so students, is this we're done with that, I like this example, okay. So students, I see this a lot. So we're just we won't do this in Eclipse. There are some common errors that I see sometimes. So in Math 140, students are writing loops, and I go, do you notice that your Boolean expression is automatically false? Right? What does I start out at 10? So we declared the counter variable inside the loop. It's initialized to 10. So you think, oh, let's add up all the numbers from 10 to 18. But what's the first thing? Isn't 10 greater than 19 is false? That's the first case. So we initialize one time, and then we evaluate the Boolean expression, then we execute what's in the loop, then we do the incrementer. But right away, that Boolean expression is false. The loop never iterates, right? We just pass over the loop. And I think and the problem is that we did greater than instead of less than by accident. But yeah, so right away, the Boolean expression is false. So really, it happens, but it's a common error I see. And it's not the computer is not going to, Eclipse, you're not going to get like a warning or anything. It's not actually a compiler. Compiler is when you get the red dot and you can't run your program. But yeah, it's just our logic is wrong. So that's why I call it a runtime error. Okay, so students, now let's get into what I call the stuff that drives us crazy. It's the stuff that drives us crazy section of the lecture. But important stuff. Do you see how I declare, and I think maybe this is why Zybooks is encouraging us not to declare the variable inside the loop. The things you can't get away. Eventually you have to learn this, so I'm going to tell you right now. I think they're taking a little bit of the easy way out and not having to present all these rules. And it does occur to me this is probably why they're doing it. Do you see how we're declaring that variable JJ in the loop? Now you have a comment, JJ declared in the loop. Well, when you do that, students, you can only use JJ inside the for loop. And we're going to talk more about that later on, but this is the first introduction, what they call scope. Some variables only exist in certain parts of the program. So JJ, see where I have compiler error? JJ can only be used in this part right here. I'll highlight it in red. And that's because JJ is declared inside the loop. So it cannot be used outside the loop. So the compiler would probably say something like, oh, I can't recognize this variable JJ. And we're definitely going to talk about scope later on. It's going to be a big issue near the end of the course. So any questions on that? And again, you don't really see this in while loops because while loops, you don't declare the variable inside the loop. So this is definitely a gotcha with for loops. It can drive us crazy. If we don't know this rule, and you go, well, how could this be? I see the declaration right there. And it's just that, there's this thing called, the scope limits the visibility of a variable. It's kind of a sophisticated concept. Okay, so this is another one that's going to drive us crazy. Do you see? Okay, students, don't let this happen to you. We love semicolons. Okay, so all Java programmers like semicolons, but it can be too much of a good thing. Okay, so don't put a semicolon at the end of like this for loop right here. They go at the end of statements like I have right here, like where it says this statement is not part of the loop. That semicolon is good. So like don't put a semicolon like if we don't like the parentheses, the right parenthesis for a Boolean expression should not be followed by a semicolon. The same thing for a for loop. Do not put that semicolon after the right percent parenthesis of a for, okay? Because it stops the loop. Basically, it's saying for k, let's initialize k to 10, and while k is less than 19, do nothing. That's all it's saying. It's not a compiler error. It's bad code, but the compiler is not going to save us in this case. So basically, all that's saying is, while k is less than 19, do nothing. And eventually, if that loop is actually good, all it would do is you'd increment k by 1. Eventually, kk would become 20, and you'd stop. Okay, but here's the problem, students. Do you see where we declared kk inside the loop? Which means, and because of that, this is probably one of the trickier examples I'm showing you, but it's common in Java. Because of the semicolon, this statement is not part of the for loop, and so this variable kk is not visible, right? So when you declare kk in the loop, it can only be used inside the loop. So in this particular instance, because of that semicolon, kk, this is the only place we can use kk. KK is not I know we can see it, but the computer says, oh, you declared KK in the loop. It's restricted to the loop. And the problem here is that the programmer put that semicolon there. That was not intended. You're trying to add up like 10 through 18. And, you know, because we love semicolons, you know, we couldn't help ourselves and we put that semicolon there. So these are two. It might look like annoying and a pain in the neck. I just want to let you know because this is common, and you might end up doing this one day. Okay, so then, so students. So one more example here. This is what the book does, or the Xi book. They declared. See how we declared KK outside the loop? Whoops. This statement right here. Okay, so if we declare KK, see we're declaring KK before the for loop, it means we can use it outside the for loop. And I think that's why the Xi book is doing it. If you declare the counter variable outside the loop, we're not restricted. It means we can use it anywhere in the program. Okay, but now once again, we have that horrible, that semicolon. It's a variation of this bad example here. Now we're declaring KK outside the loop. Now it's not a compiler error, right? Because we declared KK outside the loop, KK is visible anywhere, but see this statement is not part of the loop. Once again, because of that semicolon, this for loop ends right here. The for loop ends right at that semicolon. And so this loop essentially is just being silly. It starts KK at 10, and then, 10 is less than 19, increase KK by 1. Well, 11 is less than 19. And this statement, sum is assigned sum plus KK, is not part of the loop. And then what happens? What's the last value of KK? What's the value of KK that's going to make that expression false? And it's when KK is 19 less than 19 is false. Eventually, KK is going to get the value 19. Right? First it's 10, then we incremented it's 11, then we incremented it's 12, right? 12 less than 19 is true. Eventually, we keep incrementing KK by 1 till eventually it's 19. 19 less than 19 is false. Now we add 19 onto sum. So sum is now 19. So it's not a compiler error, we just get this bad result. Instead of adding 10 through 18, we're just adding 0 plus 19. You get this bad result. I mean, this whole loop is, even without the semicolon, it's not such an interesting loop, but it's not doing what we want it to do. But we do get output. Because eventually something's going to have to make that expression false. So I think these three examples are, if you like programming, you definitely want, I think these are good examples to learn. And so again, students, if this looks hard to you, it's like, oh my God, I'm losing him. Because to be honest, students, if I was sitting there at this point, I have kind of a short attention span, and after a while I stopped listening and I stopped paying attention. Everybody could learn it. If you just put your mind to it, you can learn it. So it's just a matter, if it interests you, you can learn it, and you have this kind of growth experience. All of a sudden you have this like, oh, aha moment, oh, I understand it now. It's kind of great, okay? Especially happens a lot in calculus, right? A lot in calculus that, at first it's confusing, okay? Okay, so students, I think I said this at the beginning of the lecture, and I'll say it again. When should we use a for loop? When should we use a while loop? So for loops are good when we know the exact number of iterations. And while loops are good when the number of iterations is unknown. And in our course, we're more likely to use a for loop. So there's very few problems that we're going to come across where we actually don't know the exact number of iterations. Like, oh, computing the greatest, in that last set of slides where we had an algorithm computing the greatest common divisor of two integers, there we needed a while loop. This problem that you have for your assignment where we're counting the number of even integers in an integer, you need a while loop because we don't know the number of integers. There's no way of telling the number of integers there's no way to know ahead of time the number of individual digits in an integer. So any questions right now, students? I did put up a worksheet here, and let's just look at one of the problems, and maybe at the next lecture, which is next Monday, we can start by maybe just going over some of I think we should do some reviewing next time instead of just plowing ahead. And so we'll go over this worksheet at the beginning of next Monday, because we've learned a lot. Like to me, I have to remember I know all this stuff. So at this point, it better be easy for me because I've been doing it for like 1,000 years. Not 1,000, but many decades. Decades and decades and decades. Okay, so where it's all new to you, and so I'd like you just need to practice. Otherwise, I just don't want to go ahead to the next topic without knowing exactly what having maybe some knowledge of it. So let me just stop sharing here, and I'm going to open up. Let's just look at one of the problems in the worksheet, and then I'll stop and I'll stick around in case anyone has questions. So I did put up this. Actually, I have another worksheet too, which I didn't put up. Harder problems. I'm not sure I'll put it up or not. Okay, or maybe I'll put up just for those of you who love computer science, just want a challenge. Okay, so let's just share this. Okay, so I think these are kind of doable. I do actually have a program. I actually have this program here. So let's look at, I think I did post this online, this program. I think this is the one let's write this one for. Find the sum of all squares. There's actually a formula for that too, which I don't know. If you take Calc 1, you have to know the formula for the sum of, you have to know this formula. You learn it, you learn the formula, you take the test, and then you forget it. This is being recorded. Everyone knows that goes on. As I said, I don't know the formula, but when I'm teaching calculus, I know the formula. Okay, so it's not a formula you use a lot. Let's try number 4, and then that'll be it for today. And I'll stick around for questions. So we want to compute 1 squared plus 2 squared plus 3 squared. And students, we're not going to use math.pow because we're doing integer. We want to add up integers. Remember, math.pow returns a double. Like, if we did let's say like math.pow 3 comma 2, that's 3 squared. That's going to return 9.0 and not 9. And there's a way of getting rid of that 0.0, but we're not going to talk about it right now. So let's just try this. So we're going to add up, we're going to do problem number 4 in the worksheet, which I'm pretty sure I put on in the module. So let's stop sharing. We'll just do this one fun program here. Let's just call it sum squares. I'll put this online when we're done. Sum squares, and let's just, I'm gonna remember to do this, saves us some time. Okay, so we're going to add up the sum of the squares from 1 to 100. Let's get rid of this commentary, we don't like it. Okay, so we need, again, students, we're computing a sum. We have to have some variable. When you're computing a sum, you always need a variable to store the sum. Oh, am I sharing this? Did I share this?
No.
Do you see it? I don't think you, did I?
No.
I did?
No.
Okay, yeah, because I didn't see you. No, I know what I'm sharing because I see, yeah, now I see everybody. Sorry about that. Okay, so in case you missed out on, this is what you missed out on, me creating a file called sum squares. Okay, and so this is the first thing I typed in. We want to find the sum of the squares, 1 plus 2, okay. The sum of the first 100 squares. since we're computing a sum, we need to have a variable to hold the sum. And I think sum is a really good variable name. And we're going to use a for loop. So for int I, we start at 1. There's nothing special about I, but it's a very common variable to see in a for loop. For int I is assigned 1. And we're going to go all the way up to 100. Okay, so when I is 101, we're going to stop the loop. And we're in each iteration, we're going to increment I by 1. And okay, so and then we basically, we just want to add on the sum of the squares. So just sum is assigned. We're going to increase sum by I times I. Each time we add on the square of I. And then when we're done, I'll keep the message simple. Sum of squares let's add on a period just for fun. Okay, sum of squares equals, what is it? I've never even seen that before. Okay, so let's run this. So let's look at the while loop. Remember, we start I at 1, and so 1 less than 100 is true. So we increase the value of sum by 1 times 1, and then we go to the I plus plus. We increase I by 1. It's now 2. 2 is less than or equal to 100. Then we add on. We increase sum by 4. Eventually, I has to get the value 101, and it'll stop when we evaluate 101 less than or equal to 100. That's false. And so when I is 101, that's when we print out the sum. So let's just run this. And I'm going to assume that that's true. As I said, there is a formula. I think it's like n squared times n plus 1 squared over. I'd have to look it up. I should have looked it up before class. It's not that important. The only thing, if you have that formula, then you could actually verify that your answer is correct. But I know that this has got to be, it's such a, I'm sure this has to be right. Okay, so look at this, students. So look how easy it is to write a program that adds up the first n squares. It's really pretty simple. And that's what I did in that first worksheet problem. So we'll go over the worksheet, and maybe I'll put up some more worksheet problems. So we'll next Monday, we'll review. So there's a few assignments up there. I think a lot of little programs. And just write me if you have any questions. And then, yeah. And then so there's the quiz, the Zybook assignments, and the programming assignments. I put up hints and suggestions for all of them. If you run into any problems on the programming assignments, I really encourage you to contact me via email, send your code, and we can also have a Zoom session. So I'm going to, and I'll put this program online. So I'll stop sharing if that's okay. But so students, I will stay here, and I'm going to put up the last, I have to go to Google. So I did upload the last session up to Google, and I have to, it takes a few hours to close. It's got to be done by now. I just forgot to upload it to Canvas. So I'll put that on Canvas, and then what I'll do is then this lecture here, first I have to convert it to MP4, then I upload it to Google, and then they do the closed captioning. But are there any questions right now? But I'll stay here until there's no more questions.
Yeah, I had something for the assignment.
Yeah, go ahead.
So since we're basically counting the even digits in integer, we have to evaluate the index and do modulus too. So if it equals 0, it'll raise the count.
Oh, say it again, Jose.
So what I was planning on doing is evaluating each index with modulus 2. So if it equals 0, it'll raise the count to 2. So I can do this. I think it asks for the sum too. Would that be a way to approach it? Because
I thought I suggest, I think you just want to count the individual. You just want to count the number of even digits in the number that entered by the user.
Yeah, and you would be able to do that by using that the car at 0.
No, you don't need the car at. You use the modulus too. You just take the mods with respect. Remember how if you use that, if you look at my suggestion here, and I said look at the example on I think, hopefully this is what I said.
It was 5.
Can you just give me a second? Let me just look at the assignment, make sure that I didn't mess up, which happens a lot. My cat is in here. She's just doing all kinds of strange things while we're talking. Okay, I'm just looking at the, yeah, so you can't see what I'm doing right now. And okay, so this is homework 4. And okay, this is the wrong version of homework 4. Okay, so let me see. I got my version and someone else's version. Yeah, because so okay. Yeah, so you prompt the user for an integer and count. Here, let me just share this. Let me just share this, okay? I'm going to go back onto. Let's just share. This is the assignment here. This is what I'm. Hopefully, this is what I'm seeing. Hopefully, this is what I put up there. It could be okay. So how to something like this, yeah. So so you read in an integer, right? So prompts the user for an integer and counts the number of even digits. So, okay, so yeah, so it's not, so you're not going to use char at because it's not a string. So if you just look at that example I have, remember there's that example in the while loop lecture where we actually got the individual digits in an integer by doing, first we did the modules with respect to 10.
Yes.
Yes, you have to do that. You take the modules with respect to 10, that gives you the number in the ones place. Okay, so when you extract that number and then you say, oh, is this an even number or not? And if it is, you increase the count by 1.
Okay, by doing modulus 2.
No, modulus 10.
No, modulus 10 to get the place, and then modulus 2 to actually see if it's even or odd.
Oh, right. You're absolutely right. I'm sorry. You're right. Yeah, to check if it's even, you do modulus 2.
Okay. So that's probably why I was confused, because I was trying to use the end, like, I got mixed up, so thank you.
Well, that's easy, because I mean, it's also a legitimate problem. Here's a string, now tell me how, count the number of even digits in that string. Yeah, so we're just gonna take it in, it's that program that I wrote on that slide, I think it's really not, it's definitely different, but it's really, it's that same algorithm, modulus 10 to get the ones place, and then you get rid of the number in the ones place by dividing by 10. And then when you've gotten rid of all the digits, then you stop the loop. Does that help, Jose? Or?
It did.
Okay. And feel free to send me your code if you want. So anybody else? No other questions about anything, or? It's okay, so I'm going to stop sharing this. And I'll just stay here until there are no more questions. Am I the only one here? Okay.
No, I think I was trying to think of if there was anything else that was.
I don't see you. Okay, but that's fine. Okay, I know 2 participants. Yeah. Oh, go ahead. Is this still Jose?
Yeah. So, is there anything else that should be implied? Because I guess, I mean, we're the ones running the counting even digits, but like the integer length or anything else.
That's why you need the while loop. Because so like if you read an integer and there's no way of knowing ahead of time the number of individual digits in that integer. So that's a perfect use of the while loop.
Oh, okay. Because then with a for loop, we would know the exact amount of iterations.
Right. When you divide a number by 10, you take an integer, like a positive integer, and you divide it by 10, you keep doing it over and over again, eventually you're going to get 0.
Okay. Okay, that makes sense.
Because when you only have, like when you have the numbers 0 through 9, let's say it's a 1-digit integer, you divide that by 10, you're going to get 0.
Oh, okay, that makes sense.
So yeah. So
there's also
go ahead.
There's another thing. Would it be a possibility to unlock all the hidden Zybook?
Oh, yeah, sure. Yeah, you want me to unlock? Yeah, sure. I'll do that. Absolutely.
I was trying to look at the previous ones and some of the like examples just to do.
Yeah, I should have done that a long time ago. I'm kind of an inexperienced Zybook teacher. It's the first semester I've used. I did use it I didn't use it for 130. This is the first time I've used the Zylabs ever. So I'm kind of an inexperienced Zylab teacher.
I feel like it really helped.
Okay, so I'll do that right now. I'll go back and I'll do them for everything from 1 through all the ones that we've done. How's that?
Okay, thank you.
Okay, and if there's anything else you need, just let me know, okay?
Thank you.
Okay, and so, okay, any other questions right now, Jose?
No, have a good day.
Yeah, you too, bye-bye.